This is Code Smarter, Not Harder with TypeScript Generics. I don't know about the rest of you, but I'm a lazy developer. I don't like to actually do work, so I like to find ways to do things that do the work for me instead, so that's kind of what this is about. That's obviously not a picture of me, but that's my dog. About me, I have about 2 years with Angular, about 16-ish years doing QA and testing in general of breaking things and making other developers very sad. I think the last two are the most important credentials. Over 20 years playing with Legos. I think that's a really critical thing. And I'm a dungeon master. So don't repeat yourself. One of those software design paradigms and acronyms we like to throw around at each other. And this is the problem that TypeScript Generics help us solve. So typical DRY problem, you see duplicate code somewhere, right? Like I've got this big nasty form group examination to know if I'm turning on or off these Angular material errors. And when we see duplicate code, we turn those into a helper function, right? We do something to make our lives easier and simpler. A lot less typing, laziness. But what do we do when the duplicate code is much larger than just a single line of code? What do we do when the duplication is something like an entire class, like a service? Can everybody see the amount of stuff that's duplicated here? How about if I hide the types? Everything not blacked out is duplicate code. So how do we solve this problem? How do we not duplicate ourselves when it's something like this? And this is far more complicated and much more work to write than just that single line of form group access code before, which is not a terrible thing to have to retype. But this is obnoxious, right? If I'm trying to make a new service for accessing a CRUD API, I have to write 50, 60 lines of code. I have to remember exactly how all this stuff works. It's annoying, it's painful. So TypeScript Generics to the rescue. So we start with a sample service, in this case, a student service, which has a fetch all for getting all of my students, get by ID, there's a create, there's any number of functions down here below in the service. And we make an abstract version of this service. We start by giving our service a name, in this case, base CRUD service. And you'll note the abstract keyword in front of class. That tells the compiler this is a class that cannot itself be instantiated. You cannot do new base CRUD service. That's an illegal operation because abstract things cannot be instantiated. So some other class will have to extend this in order to make this a reality. So that abstract keyword is very important here. Then we remove things like student and replace it with a variable, t in this case for type. It can be whatever letter I want. But in this case, our code starts looking a little bit more like algebra, right? You start adding letters instead of numbers and things. But what this does is this is now building out the generic version of this service. Generic because t can be anything that qualifies as a type. Could be an interface, could be a primitive, could be a class, anything that can be on the green side of a declaration, anything that's fine being here on the type side, you can swap in for t. The other things we have to do is mark a couple more things as abstract. Our endpoint and URL need to be defined by whatever is implementing this class, right? Again, our goal here is to make a generic CRUD service. So we don't know what the endpoint's going to be at this level, at this generic level, but we do know that there needs to be one. And we want to be able to rely on the fact that there is one. So by marking it as abstract, we can rely on it later in the file, and that's a valid thing to rely on. Because we're establishing it exists. We don't know what it is. We know it's a string. But in the rest of the abstract class, we can rely on that being there. And the other change here is inside the constructor. The HTTP client dependency injection needs to go from private to protected. And that's because we need to share that reference with the child, the thing that is going to extend and instantiate the abstract. We have to loosen this up a little bit and not make it private, but make it protected. So how do we use this thing? We've built this abstract class with our T types and abstract things, but now how do we use it? It looks something like this. This is what our new student service looks like. The first thing is we extend our base CRUD service, and we feed it the type that we're working with, in this case, the student, which is just an interface. We have to call super in our constructor now, because we are extending something. We have to make sure that the thing that we're extending, its constructor gets called, and we do that by calling super. And in this case, our generic service is expecting a reference to the HTTP client. Now, because this is an abstract class and doesn't actually exist and can't be instantiated, this can't happen via dependency injection. So we have to, in our service, ask the dependency injector to get this for us so we can pass it off to the abstract. And then finally, we implement our endpoint and our read-only URL. So that's what using this looks like. Now, I don't know about you, but that service looks a lot simpler and a lot easier, and I can probably write that a lot faster than the ones we saw at the beginning, right? So the value of doing this. All of my future CRUD services that are going to use that same pattern that I established in that base are this big. That's it. I can make a CRUD service in about 8 lines of code. Done. I get my fetch, I get my create, update, delete. Anything that was in that base is now here. It's just hidden away. It's abstracted away. Because there's nothing new here, there's really no unit testing required for this, other than maybe checking that the endpoint is what it's supposed to be and the URL is what it's supposed to be. What is there to test here? Which is kind of interesting. Now I'm saving even more time, because all of the work lives in that base CRUD service, which should be fully unit tested, of course. But for this, there's not much. You can still write tests for this service if you want to. You can write tests for all the same services. But there's no real new code here. Another valuable piece here, consistency. All of your CRUD services that use this kind of a thing are now exactly the same. So now you have a very common surface. So if you have a large team and everybody's dealing with large pieces of code, everybody now understands all CRUD services look the same. There's expectations you can build with your team members on what this should look like, what kind of things a CRUD service might have to offer. And lastly, if you want to make a change to all of your CRUD services, like you have to update the pattern for some reason, we decide we now need some sort of new method on it. We want to make all of our services caching services. We want to make all of our services be their own route resolvers. That's a fun thing. You can now do that at the base CRUD service level, and it's applied to everything that inherits from that all at once. So that was 8 minutes. Do you guys want to see some live coding real quick? See this in action? Because what could go wrong? What could possibly go wrong, right? OK. So here I have an app which has a student form and student list, which you cannot see because, let me just swap my display settings here. Now you can see it. All right. So I have a very, very simple Angular material app here. I have a list of students, a student form. I can edit one. We'll get rid of a major. We'll update. The app reloads. And now Jeff Winger is no longer studying criminology. I also have instructors. We can edit them, do various things. We can add a new student, etc. Nothing super novel here, just showing you I have 2 completely different feature sets that are doing the exact same thing, right? Basic CRUD operations. So these should look a little bit familiar. Here's a student service with a whole bunch of cool stuff. And here's an instructor service, which looks pretty much the same. In fact, if I do this, and we look at these, they're basically identical all the way down. It's easy to recognize when we have duplicate code at the single line level or the function level. You see the same little helper function copy pasted into 15 components. This can be a little bit harder to spot, but you'll know it when you see it. When you start seeing entire components or services that are pretty much the same thing. When the way you build one of these is to grab an existing one and copy and paste the whole darn thing, and then just swap out the types, which is exactly how one of these got built. That should tell you I have an emerging pattern. I have something that is repeating. This is a thing I can abstract away, and I don't ever have to deal with it again. So let's turn these into neat and tidy little services. So I'm going to grab the Angular console, which is just a GUI wrapper for the CLI. We're going to make a new service. We're going to throw it in our services folder, call it base CRUD, pick our application, turn off flat. We should see, it's not what I'm expecting to see. I should see app services. There it goes. So this is what I'm expecting to see. I'll hit run. All right, so now I have my new service. If I head back here, I have my base CRUD service. Right, empty, brand new service from the CLI. Cool. So let's grab the entirety of the student service, drop it in the base CRUD service. Give our type abstract in front of our abstract. Now again, in our base CRUD service, this is not going to be students. It's just going to be a string. It'd be nice to leave this around. And in fact, the better way, instead of having to actually make this abstract, would probably just to make this a getter function, because then it doesn't have to refer to the problems. But because it doesn't like accessing that endpoint, we'll just make it a string. So then we need to get rid of every occurrence of student, which is where Control-D becomes our friend. Let's just copy every version of student and call it T. And then some of these need to be renamed because they're not actually types. They're just generic items. Now, can anybody recognize what might be going on about line 30? Yeah.
You didn't tell T that it had to extend an object that had ID on it.
Bingo. So when we're looking at generics, the compiler only has access to information that we give it. In this case, T is anything. So how on earth does the compiler know that T, because item is of type T, has an ID? So if we go to our models, make a new one. And we make a base item. And what we can do is we can go to our person. And extend base item, which is what gives us our numerical ID. And just for completeness, instructor and student simply extend person with their custom pieces. So now all of my models have that base ID from base item, which means we can cheat and tell it T should extend a base item, which means now the compiler can rely on the fact that T, because it extends base item, will have an ID property. Other cool benefit, if all of my models extend that base item, and my backend devs decide we're switching IDs from numbers to UIDs, fine. I go to base item, I change it to a string, I modify my base service to handle strings instead of numbers, and my entire application realigns to what my API devs just did to me. So, the power of generics. Okay, cool. So I have my base CRUD service. Let's go here into the student service now. And let's nuke all of this. Extend base CRUD service with type student. And the complaint there is difference in types, I believe. What's the complaint?
Not protected in the base.
Ah, thank you. Cool. So now I've implemented my student service as an extension of the base CRUD service. You can see the app live reloading down here in the bottom. If we come back, I can still edit something. We can give Jeff Winger criminology again. And the service still works just fine. And now if I want to go make a new service, like let's say classrooms, right? If I'm building out a educational scheduling application here, and I want to make a new class service, all I do is I make my class object, make a new service. It's going to look just like this. And now I've made a brand new, fully featured CRUD service in as fast as I can type about 5 lines of code. So this is what tackling DRY looks like at the larger level. I used services for this case, but again, you can imagine how much code is reused in the list component for a student and for instructors. Or the forms, because this is just a form component and a list component in a wrapper for instructors, and that pattern is repeated for students. And it could be repeated for classes and buildings and whatever else I might need to do for my basic CRUD operations. In fact, this code repo is the code for this application that you saw during the live coding. And in here are code examples about what it looks like to build out abstract models and classes and services. Another fun application here, making mock CRUD services so you can use them in your component tests. You could make a mock base CRUD service that implements fakes of the exact same signature of your real CRUD services, and now making a mock for any new service is as easy as about 2 lines of code. And now I can use that in my unit tests for my components, and I get all of it for free. Super quick and easy. So, takeaways from all right. DRY applies to all levels of our applications. We saw that in the beginning with just a couple lines of code, and then with functions. We can do it with entire classes, whether they're services, components, pipes, whatever it might be. So start recognizing those larger patterns. Use generics to abstract away that common boilerplate crap so you don't have to keep typing it over and over and over again. You'll get faster, your stuff will be more consistent. And eventually, after you figure out what part number 3 is here, you'll have profits, which is always good. If you're going to take a picture of a slide, this is the one to take a picture of. This is how to get a hold of me. This is a link to the slides and a link to the code. I think these will all be going out afterwards anyway. But that is TypeScript Generics in 12 minutes. So there you go.